I'm going to walk you through the idea behind the chain rule. By the end of this video, or maybe a couple of videos, we'll see how long this takes, you're going to be able to derive and use the chain rule to find derivatives of compositions of functions. Let's make sure you know what a composition of functions looks like. So let's say we're given y is sine of u and u is equal to x squared. You could rewrite that y is sine and x squared is the input of sine. Why does that matter? Well, you should be able to take the derivative of sine of u, but we have to be careful on our notation. So that's going to be dy over du is cosine of u. How do you take the derivative of u is equal to x squared? Well, we know the derivative of x squared is 2x, and we're treating u like we would normally treat y. So the notation there is du dx, meaning the output variable is u and the input variable is x. So let's step back for a second. We thought of the composition y is equal to sine of x squared. I'm having trouble going back and forth here. Y is equal to sine of x squared. If you were going to take the derivative of sine of x squared, that would take the form dy, output variable, over dx, and that's really what we're looking for. Well, if you notice, we have dy over du and du over dx. Dy over du multiplied by du over dx should give us dy dx. That's what we want, the slope of y with respect to x, the instantaneous rate of change of y with respect to x. So let's fill in the rest. Dy over du is cosine of u. Du over dx is 2x. I'm going to rearrange a little, so I'm going to write the 2x first, and that's multiplied by cosine of, and then I'm actually going to not write a u. I'm going to replace u with what u is equal to, x squared. So let's think about that in a different direction. If we're given y is equal to u squared and u is equal to sine of x, we're thinking y is equal to sine of x inside the squaring function. The derivative of y is equal to sine of x all squared is what we're looking for. But we're going to do each piece of that separately. So first I'm going to say, what's the derivative of u squared? We're going to say dy du is 2u. What's the derivative of u equals sine of x? Well, we know the derivative of sine of x is cosine of x. On the left-hand side, I'm going to write du dx is equal to cosine of x. So dy du multiplied by du dx is going to give us dy dx. So we have to go back and fill those pieces in. That's going to be 2u replacing dy du, or equal to dy du, and du dx is cosine of x. So we're almost done. Dy dx should only have x's in it, and u is equal to sine of x. So 2 sine of x, replacing the u, and cosine of x. This is the form you would normally see a composition of functions when you're supposed to take the derivative. Can you tell what's the inner function and the outer function? That's new terminology. Let me go back and say what I mean. Back here, the outer function was the squaring function. When we composed, we put sine of x inside of u squared. So we're saying the outer function is the squaring function. What's the outermost function here? It's the cubing function. So we're going to say u is equal to cosine of x, that's the inner function, and y is equal to u cubed. Eventually we're not going to have to write all of this, but we need to get the basics first. So what am I going to do now? Eventually I want dy dx, which is the derivative of cosine cubed x. For now I'm going to do that in pieces. I'm going to write du dx, let's see, so what's the derivative of cosine of x? That's negative sine of x. I'm running out of room, so I'm going to write this actually off to the right. Dy dx, oh, not dy dx, dy du is going to be 3u squared. I assume you're okay with the power. So we're going to say dy du, which is 3u squared, multiplied by du dx, which is negative sine of x. And we're going to get dy dx, du's divided, is 3. I don't want a u. What am I going to replace with u? Cosine of x. Let me erase that. I don't like that. Cosine squared x times sine of x, and I'm going to put the negative way out here in front with the 3. Let's do that again. Can you find the inner function and the outer function? Hopefully you said the inner function is sine and the outer function is cosine. So we'll say u is equal to sine of x, which makes y equal to cosine of that other function u. Du dx, the derivative of sine, is cosine of x. And dy du is negative sine of u. So dy du, let's make that look like y, is multiplied by du over dx is equal to negative sine of u multiplied by cosine of x. Let's simplify. Dy dx is equal to negative sine. We need to get rid of that u. What was u equal to? Sine of x. And then that whole thing is still multiplied by cosine of x. I think you know where I'm going. The inner function is 4x squared, so we can think of this as y is equal to cosine of u, and u is equal to 4x squared. Dy du is equal to negative sine u, or negative sine of u, and du dx is 8x. Maybe we can do a little bit less writing. I'm just going to jump to dy dx. I know I'm multiplying dy du over du dx. So what could I write? Well, I'm going to write negative sine of u times 8x, but I'm going to replace that u with what u is equal to. So what am I going to write? Maybe I'll do this in 2 steps. Negative sine of u, and then multiply by 8x. What is u? U is 4x squared. That's up top. And so let's rearrange so this looks a little prettier. Negative 8x multiplied by sine of 4x squared. The reason I put the 8x out front is that way it is very obvious that 8x has nothing to do with the input of that sign. So hopefully by now you're starting to realize we're writing the same things over and over. And what we're writing is, we're writing dy du multiplied by du dx But let's take a step back and think about what that means. dy du, if we keep breaking things apart the same way, is the derivative of the outer function. So here, the derivative of that outer function cosine was sine. Back here, dy du is the derivative of this outer function cosine, and that derivative is negative sine. With the same input, still u. Back one more. The outer function here was the cubing function, so dy du, the derivative of that outer function with respect to u, was 3u squared. So here, we're gonna try to write less. The derivative of the outer function, which one's the outer function? That's the cubing function. That's going to be 3 times something squared. Now we have to figure out what that something is. Let's go back and look again. dy du was negative sine of u when y was cosine of u. Those have the same input. Back here, y was cosine of u and dy du was negative sine of u. Those have the same input. Go back one more. The outer function here is u cubed, or something cubed. What is dy du? That's 3u squared. 3 times that same input squared. Okay, back to our new problem. So dy du is what we have written. 3 times whatever u is squared. Well, u is that same 2x minus 7. And then what would du dx be? That would be the derivative of the 2x minus 7. What's the derivative of 2x minus 7? 2. So we can say dy dx, let's combine the 3 and the 2, is 6 times the quantity of 2x minus 7 squared. Let's do that a little bit quicker. So our answer is going to take the form dy dx. The 3 is a constant multiplier, so I'm going to ignore that for now. What's the outer function? It's sine. So the derivative of sine of something is cosine of something. And our something is our something is 2x cubed. And the derivative of 2x cubed is 6x squared. What's the outer function here? It's the squaring function. Sorry, my touch screen is too touchy. The derivative of something squared is 2 times that something to the first power. Our something is 1 over t minus 3, which has a rate of change of negative 1 over t minus 3 squared.